Hello everyone, welcome to the channel. In this video, I am going to show you the full modding workflow for Resident Evil Requiem, step by step. We'll handle all modding process inside Blender, a powerful and free 3D software. We will use RE Asset Library add-on to extract the game assets, RE Mesh Editor add-on to export and import mesh and material files, RE Chain add-on to handle physics, and the Fluffy Mod Manager program to install the mod in the end. In this tutorial, I am modding Grace and swapping her full body model with a brand new 3D model. By the end of this video, you'll be able to do the same with any character you want, or any 3D object. So if you are ready, let's begin. Let's start by downloading Blender. Go to the Blender official website and download it like this. The link is in the video description. All the links are in the video description. This is Blender version 5, the latest one at the moment. Any version above 4.5 will work just fine, but I get the latest. After downloading it, you will get an installer file. This is it. Simply run it and follow the instructions. It's a very simple process, just like installing any regular software. Once it's finished, close it, don't run Blender just yet, and leave it. And let's move on. Now let's download the add-ons. Start with RE Asset Library. Go to this GitHub page, the link is in the video description. Scroll down a bit, and click on this Download RE Asset Library link. This will download you a zip file. That's what we need. Alternatively, you can click on this green code button in the top right corner and select Download Zip. That will also download you the zip file. Next, download RE Mesh Editor. Go to this GitHub page, scroll down, find the download link for RE Mesh Editor, which is this, and click it. It will download you a zip file, just like before. Done. Now, download RE Chain add-on. Go to this GitHub page, scroll down, find the download link, this is it, and click it. Again, it will get you a zip file. If you have WinRAR or zip, you will see something like this. Here are my downloaded add-on zip files. Place them somewhere you can easily access, and leave them as a zip file, don't extract them. Next, we need to open Blender. We already installed Blender, right? So go ahead and launch Blender, and let's set everything up. After you launch Blender, this is what you'll see. In the startup menu, which is this, click General to start a new project. And now we are inside. This is Blender. Welcome. Let's start. First, in this scene, box select all of these objects like this. Then press the delete key to remove them. After that, go to the bottom of Blender and you'll see the timeline editor, this window. Hover your mouse over the borderline like this and drag it upward to resize it. Make it bigger. Then leave it there. And if this small bar at the bottom bothers you, you can also close it like this. Now we have a clean workspace to work with. Nice. Now it's time to install the downloaded add-ons. Go to the top left and click Edit. Then click Preferences. A new window will open. This is Preferences window. On the left side, go to the Add-ons tab. Here, you can see the currently installed add-ons. All of these are add-ons. We need to install the new ones as well. To do that, go to the top right corner and click this small arrow. Then choose Install from Disk. A browser window will open. Here, locate your downloaded add-on zip files, the ones we downloaded them from GitHub. For me, they are all in this directory. So I navigate there, now I have them. Once you find them, select them either one at a time or all together. It doesn't matter. I select all together and then click the Install from Disk button. After a few seconds, they will be installed. You'll see them appear in the add-ons list. The search bar may automatically show their names. If you clear the search bar field, you can see them listed here. We need to do this for all of them. Make sure all 3 add-ons are installed. Make sure they are all checked and enabled, like this. Now we need to configure one of them, RE Asset Library. Expand it like this. You'll see several options. Find Download RE Asset Library, this one, and click it. A small window will open. Here, change the setting. In the RE Asset Library section, open the drop-down menu and select the game you want to mod. We have lots of games here. We are modding Resident Evil 9 Requiem. This is that option, so I select that one. After that, we click the Download Asset Library button and wait. Blender will freeze during this process, and that's normal. Just wait. The add-on is downloading the data in the background. It will take a few minutes, depending on your PC and network. Once it's done, Blender will become responsive again. And there we go, it's done. After it's finished, simply close the add-ons window because we are done here. Now let's move on to the next step. Now we need to bring the game files into Blender, and this is how we do that. Go to the timeline editor at the bottom, this. On the left side, there is a drop-down menu. Click it, and this panel will open. Here, you can select whichever editor you want, and this window will become that editor. Right now, we are on the timeline, but we don't need that. The one we need is called Asset Browser. It's located under the Data section. This is it. Simply click it, and the editor will switch to the Asset Browser. There we go. Now, this will show us all the asset libraries for Blender. Right now, it shows all available libraries, but we only want to work with Resident Evil 9, so let's limit it to that. Come to this section and open the drop-down menu. You'll see an option called RE Asset RE9. Select that one. That's the library we just installed earlier. We downloaded it from Library Asset add-on. Once you select it, all of these files and the categories on the left side will now belong specifically to Resident Evil 9. From here, we can easily open any of these assets directly inside Blender and start editing them, start to mod them. And this is how you do it. Now, we do have the files' names and icons here. But before we can import them, we need to set up the game path so Blender knows where the game files are and can be able to extract assets from them. You get the idea, right? So let's set that up. After you set the category to your desired game, in my case RE9, come to this drop-down and click on it. Here you'll see several options. Select Set Game Extract Path. This will open a new window with 2 options. In the GameX file path, you need to point Blender to the exact location where the game is installed. And here is how you can find that. Go to Steam, right-click on the game icon, go to Properties, and in this window, go to Installed Files, then click Browse, and this will open the folder where the game is installed. Copy the path from the address bar at the top, like this. Now, go back to Blender, click on this in the GameX file field, and in this browser, navigate to that same folder. Inside it, look for the game's X file. There should be an re9.x file. Select it and confirm. Alright, that part is done. Next is the extract path. This is the location where Blender will extract the assets from the game's original files. You can select any folder you like, all of them works, but make sure the path is short. If the path is too long, it may not accept it. This is the folder I select, and it works perfectly fine. Finally, set the platform to Steam. Then click OK. And that's it. Now we are ready to extract and import any of these files we want. Let's do that. First of all, let's find the model we want to modify. In the asset browser on the left side, we can choose categories. They are very clear and organized. So what do I need? I want Grace's 3D model. That would be inside the characters folder. Why? Because Grace is a character model. If I expand the characters folder, I can see all the characters folders. I look for Grace, which is this one, and this one is for Leon. So you see, they are very clear. When you select these character folders, the asset browser will show all the assets that belong to that character. So in the Grace folder, as you can see, these files are related to her, and only her. The 3D model I want is the default body model. So I go to default folder. I am planning to replace the entire default model with my new one. But if you look in the asset browser, you'll notice that the character model is separated into multiple pieces. For example, one object for the torso, one for the legs, and separate ones for each arm, left and right. So how does that work? How do we know which piece belongs together? Do we replace them one by one? It's actually pretty simple. First, look at the character in the game. Pay attention to what the character is wearing, and how the model is structured. You can also use the model preview section. It helps a lot. Using this, you can usually tell which parts belongs together. For example, which torso belongs to which legs. Also keep in mind that sometimes different outfits uses the same model piece, and that's completely normal. Now, inside the asset browser, you can identify these model pieces by looking at their icons and the names too. Each asset also has an ID number. For example, this torso is called Grace Default Torso, followed by the number 00. That 00 is the ID. If you find another object with the same ID, like this Grace Default Legs 00, that confirms those pieces belongs together. So the ID number can help too. Now the next question is, how do we proceed? Each of these pieces has its own armature. Armature is the skeletons of the model, which is used for animating the model. If you want to edit these models separately, then you would also need to split your new model into separate parts as well, just like the original ones. But that's not what I am doing here. I have a full body model that I want to replace the original model with. So in that case, the best approach is to import all the original model pieces into Blender and merge their armature, creating one complete armature for the entire model, for all pieces. One skeleton for all pieces. That works much better for this type of replacement. So here are the pieces we need for this character. Grace Default Torso 00, Grace Default Legs 00, Grace Default Left Arm 00, Grace Default Right Arm 00, Grace Default Head 00. And we don't need the hair. If you want to mod the hair, it's better to do it separately. Now I'll start importing these pieces into Blender. It's time to import, and this is how. We just drag and drop the model into the scene. Simple as that. After a few seconds, an import settings window will appear. This is it. Here, for the first imported object, leave all the settings at their default values. And then simply click OK and wait until it's done. It's importing. It will take a few seconds. And there we go. Now we have Grace's default torso 00 model inside Blender, ready to be edited. Now, what about the rest of the pieces, model pieces? Well, we import them the same way. Find the assets and drag and drop them into the scene. This time, I go with the legs. But hold on. We need to change very important settings in the Import Settings window. This setting is called Merge with Armature. This is it. Click this field, and you should see an armature listed here. This is the armature from the first model we imported, which in my case is the torso. If I select this armature, the new model, in this case the legs, will merge its armature with the torso armature, which is exactly what we want. So here, select the armature from the first imported model. And that's the only setting we need to change. Now hit OK. And it doesn't really matter which piece you import first. And now both objects are in the Blender scene and share the same armature. Now let's import the rest of the model pieces. And then we'll check everything. Just like before, drag and drop the next piece into the scene. When the Import Settings window appears, go to the Merge with Armature field, and you will see the armature listed there, the same armature. Select it. So this new model's armature merged with the existing one. Repeat this process for the remaining parts. Each time you import a new piece and merge it with the existing armature. The bones from that object will be added to the same armature, combining everything into a single rig, which is exactly what we want. So in the end, I imported torso, legs, left arm, right arm, and head. All of them are now merged into the same armature. And now everything is inside Blender, fully assembled and ready for us to edit. Okay, the next thing you need to know is how to navigate inside Blender, and this is how. You can use the tools on the right side to navigate in Blender. Rotate around the model, move around the model, zoom in and zoom out. All of that can be done using these icons. Or you can use shortcuts, which is what I usually do, what everyone usually does. Press and hold middle mouse button to rotate around the model. Hold the Shift plus middle mouse to pan around the model, like this. Use the mouse scroll wheel to zoom in and zoom out. And press the Home key to reset the view. That's all you need to know. Now let's move on. After we get the model into the scene, it's time to start editing. Now, in order to start editing, I'm going to switch the workspace for better visibility and accessibility. At the top, in this bar, we are in the Layout workspace by default, right? Switch to the Modeling workspace, which is this one. We'll do our editing here. First, zoom in on your model and get a good camera angle. Now, at the top left, we have a section for modes. Blender has multiple modes. Make sure this is set to object mode. After that, go to the top right, where we can switch the viewport, which is here. And by default, it's set to solid. There is another option called Material Preview. Switch to that. When you switch to Material Preview, the model's textures will be displayed as well. Now we can see everything in more detail. Very good. Now let's inspect the model and see what we have here. Go to the top right, this window here. It's very important. It's called the Outliner. In the Outliner, you can see all the imported files inside Blender. They are organized into collections. You'll see red collections. These contains the 3D mesh files, the 3D objects. And then we have blue collections. These contains the materials of the 3D mesh files. If you expand the red collection, you'll see this entry here. This is the armature of the imported model. We should only have one in the first imported models collection. The rest of the collections should have only just 3D objects, no armature. In my case, if you plan to replace the whole model, it's the same for you. Now, when you select it, the bones will highlight it on the model. These bones are used for animations, which is very important. Now, if you expand it even further using this small arrow, you'll see all the mesh objects it contains. Each one of these is a separate piece of the model. You can use this eye icon here to hide and unhide them. This will be useful later. And the faded objects you see here are the models that belongs to the other collections. This simply indicates that the armature is also controlling those objects, which is exactly what we wanted. Now, if you expand the objects, which are these, then this, you'll see the materials assigned to each mesh, each object. This red thing is the material. Materials are used to assign textures to the 3D models, and the textures are these images. They are image file. Without them, the model would look colorless. So yeah, that's basically the structure. These collections and files in the outliner for the original models must stay exactly as they are. Do not rename anything, and do not modify their structure. Leave them as default. For now, we edit them after we finish setting up the new model. For now, only hide them if you want, and close these MDF collections. So we get a, clear view, more space, and it makes things simpler. Let's also close the red collections too. Only keep the one that contains the armature open. Like this. Okay, the next step is to get our custom 3D model and import it in Blender. Then replace it with this original model. A good place to start is DeviantArt. Many artists there share useful and simple models that work well with Blender, and most of them are free. Usually you just click a download button and you get the file. I also have a separate video where I explain how to find 3D models for free and prepare them for modding. If you want more details on this, you can check that out, but it's not required for this tutorial. Now, this is the model I am going to use. It's available on my Patreon alongside many other 3D assets. This is perfect for demonstration purposes, but it works just like any other 3D model you might download from the internet. It's just simpler and more efficient for modding. Alright, after you download your 3D model, it might come in different formats. For example, you might get an FBX file, which you import directly into Blender. Along with that, you might also receive a separate folder for the textures. And sometimes the model might come as a blend file instead. In that case, you simply open the file and Blender will launch with the model already inside it. In my case, I have an FBX file for the model and a texture folder that contains all the textures for it. Before we start modding, it's a good idea to check the model first. So I open Blender again and start a new project and delete everything in the scene. And in the modeling workspace, I am ready to import the new model and check. Here is how to do it. Go to File in the top left corner. Then go to Import. You'll see several options here. These are the formats that Blender supports. My model is an FBX format, so I select FBX. Then in this browser window, I find and select my model file, which is this one. Leave the settings at default and click Import. Now the model appears in the Blender. Let's check it out. Everything looks good, but there are two important things you should verify. First, your model should have an armature. We need armature so we match the pose of the original model. Second, your model should have textures. We need textures so our model have colors and details. At this stage, you can also edit the new model if needed. For example, you might want to remove parts you don't plan to use. As an example, I delete this piece. To do that, make sure you're in object mode Then select the object, click on it to select it, then press the delete key on your keyboard, and it's gone. I am also going to delete the hair and the head for the new model. Why? Because I plan to keep the original head and hair for grace. If the head and hair are separate objects, this is very easy. Just select them and press delete, right? But sometimes the model is attached to the body mesh. For example, in my case, part of the head is connected to the main body object, so we can't simply delete the whole object, right? That's not what we want. In that situation, here is what you do. First, select the object, the one you plan to delete its parts. Then go to this drop-down at the top left and switch from object mode to edit mode. Once you do that, the model will appear as vertices, edges, and faces, basically lines and dots. Now choose a selection tool. You can click and hold on the selection icon, which is this, and pick whichever one you prefer. I go with this one. Then select the parts of the mesh you want to remove. In my case, the head. Once selected, those areas will highlight it in orange. Now, after you selected them, press the delete key on your keyboard, and you'll receive several options. Choose vertices or faces here, and the selected parts in the model will be removed. Simple as that. And a helpful tip, you can enable wireframe mode and X-ray mode, which are these ones. This makes it much easier to see and select parts that are inside the model. From both sides, you can select at the same time, and you won't miss any part, which can be very useful. So go ahead and delete any parts you don't need, and once you're done, switch back to object mode. Once you're done checking everything, we need to export the model. So we go to File, Export, and FBX. Go with this option. Best format to use for modding. In the export settings on the right side, go to the Armature section and disable the Add Leaf Bones option. This isn't necessary, but it's nice. Then export the model anywhere you like, with any name you like. Now the file is ready to be used in your modding project. Now that we have the 3D model file and the texture files, let's move on and replace the original Grace model with our new one. Alright, back to our Resident Evil Blender project. After importing all the original character model pieces and getting them ready, we can now add our new model on top of them. In Blender, go to File, Import, then choose your model's format. In my case, that's FBX. In the browser window, locate your new 3D model file. Mine is this. Select it, and click Import. There is no need to change any settings. Give it a moment, and there it is. As you can see, the new model appears on top of the original one. Good. Now let's move on to the next step. In the outliner, you should now see the content of the new model. Here is the armature, and if I expand it, I can see the objects attached to it. If your model doesn't have an armature, you only see the objects. It can still work, but it usually won't look very good because we can't match the pose, not properly. So it's best to use a model that already have an armature. Okay, select the armature of your new model, and make sure you're in object mode. And look at the tools on the left. Move, rotate, and scale, these three. First, select the scale. Now on your model, you'll see colored handles, red, green, and blue, which scale the model along specific directions. And the white circle scales the model uniformly in all directions, which is what we want here, which I prefer to use. Click and drag the white handle to scale the model down or up until it closely matches the size of the original character. Okay, the size looks good. After scaling, use the Move tool to adjust the position if needed. and the rotate tool if the model needs alignment. The goal is to match the size and position and alignment of the original model as closely as possible. The closer the better. And this is how we do that, in object mode using move, rotate, and scale tools. You can also select individual objects instead of the armature if needed. And you can hold Ctrl to select multiple objects in the outliner, or hold Shift to select multiple objects in the scene. Then edit all at once. It's just a tip. And another tip. Sometimes the transform tools like move, rotate, scale may appear in an inconvenient position, for example at the bottom of the character instead of the middle or corner. To change that, first make sure the object or the armature you want to adjust is selected. Then hold Shift and left click where you want the center to be, usually the middle of the model. Place the 3D cursor there, this thing here. Next, go to Object at the top, this, then go to Set Origin and click Origin to 3D cursor. This moves the object's origin point to that location, which makes adjustment and scaling the model much easier. It's something we sometimes need, especially when you're zoomed in and working on a specific part. Just wanted you to know this. It helps. Okay, the size and position match the original model. We are ready to move on. Alright, after adjusting the size and position and angle, the next step is to adjust the pose. We need to match the pose of the original model. And to do that, we'll be working with the armature. Before we start, let's hide the original model's armature, so we get a clear view. You can also adjust the viewport to whatever feels most comfortable. Now select the armature of the new model. Now on the right side, in the bottom, you'll see this panel. It's called Properties Editor. It's very useful, and we'll be using it a lot. Click on this Object Data Properties tab here, the green icon. Then here, look for the Viewport Display section, it's this one, and expand it. Here, you'll find several display options. Open the Display as drop-down, and you'll see different ways to visualize the skeleton. These options change how the bones appear in the viewport and can help you make them easier to see and work with. I usually switch to the stick mode or use the wire, which keeps things simple and clear. There is also an option called In Front. If you enable this, this lets you see all the bones through the mesh from any angle, which is very useful while posing especially. So adjust these settings however you please. These won't affect the modding process. It's just for your convenience. Now we are ready to start working on the pose. Alright, to pose the model, first we select the armature, and once it's highlighted, go to this drop-down menu and open it. These are the mode options in Blender. What we need right now is the pose mode, which is this one, so select that. Now we can start editing the pose. To do this, simply select a bone or multiple bones at the same time. You can click them individually or box select them. Then use the tools on the left, move, rotate, and scale, to adjust them. In most cases, rotate is the main tool we use in the pose mode to adjust the pose. Your goal here is to adjust the bones so the new model matches the pose of the original model. The process is simple, but it takes time, lots of time. Here is the method I usually follow. I start with the pelvis area. Adjust the bones around the hips first, because those bones affect all other bones. And once that looks good, I move to the other bones. I usually move to shoulders next, and begin adjusting the arms, making sure they are matching the original model's pose. And sometimes the arms might be shorter or longer, So now you need a different tool. In those cases, you can use the scale tool. You can fix the length with the scale tool. And some tips. If you press Ctrl plus Z, it will undo the movement. And if you press Shift plus Ctrl plus Z, will redo the movement. And if you want to reset the pose, simply select the bones you edited or select all the bones. Then go to the pose at the top menu, choose Clear Transform, and click All. This will reset all the changes you made and it will return the model to its original pose, so you can start fresh. Okay, my shoulder looks good after the edits I've done. After the shoulder is done, I move down to the elbow and try to match the elbow. Then after the elbow is done, I move to the forearm, just following the natural structure of the arm until you reach the fingers. Simple. Now for the fingers. Each finger has multiple bones, so adjust them carefully one at a time. We don't want strange looking hands. You see, fingers are important because you need to get a good grip of objects in the game. If they are not matched perfectly, then your hand will clip through the objects, like your gun or anything you hold. There is no trick here, just rotate, move and scale until the pose matches the original. Okay, I am done. This is how it looks. This is perfect. If you get this result, you're good to go. Once one hand is done, we move to the other side, the other hand. And there is a copy and paste method that can very help here. Select the bones you edited on one side. For me, they are these ones. I box select them. And don't worry if you select some other bones as well. Then I press Ctrl plus C to copy the movements, to copy the adjustments. Then I select the corresponding bones on the other side. For me, they are these ones. And I press Shift plus Ctrl plus V to paste the mirrored pose adjustments. And as you can see, it mirrored. Perfect. This works most of the times, but not always. If it doesn't work, for various reasons, you may need to adjust the other side manually as well. So do that. After the hands, move on to the legs. The legs are usually simpler. You can use the same method. Adjust one side, then mirror the pose to the other side by copy and pasting. You can also select both leg bones at the same time and adjust them together if you want identical movements. That works too. After those done, finally, check the neck bones. Neck has some bones too. And any other parts that might need small adjustments. Okay, I am finished. Once everything matches the original pose, we are ready to move on to the next step. Switch back to the object mode from here. The next step is to make the original model's armature control the new model. Right now, in object mode, if we select the original armature and go into pose mode and move some bones, only the original model moves. But we want the new model to move with it, so the in-game animations, will also affect our new mesh. Here is the easiest and most efficient way to do that. While in object mode, go to the outliner and select the objects of your new model, one at a time. Then go to the Properties editor and open the Object Data Properties, the green icon. Here, you'll see two important sections, Vertex Groups and the Shape Keys. Expand both. Make sure you follow this in order, otherwise it won't work. First, check Shape Keys. If there are any, either apply them or delete them using this option. And don't touch Vertex Groups yet. Now, while the object is still selected, go to the Modifiers tab, the wrench icon, this one. If your model has an armature, you should see an armature modifier here, just like this one. Click on this and select Apply. And if you have any other modifier, you might want to apply that first before applying Armature modifier. But if you don't, then just apply Armature modifier and you're set to go. After that, go to the object data properties again, and this time go to the vortex groups and click on this and choose delete all groups. Make sure none of them left, and you're done. Repeat this process for each object in your new model. Only new models, don't touch original ones. And do this one by one for new models. So the correct order is apply or remove shape keys, apply the armature modifier, delete all vortex groups, and that's it. And I am done. Once that's done, select the new model's armature from the outliner or from the 3D viewer. Then press Ctrl+A and choose Apply All Transforms. Click on this option. Then press the Delete key on your keyboard to remove that armature. And it's gone. That's what we wanted. Now the model is cleaned up and ready to be assigned to the original armature. And here is how we do that. In a model's skeleton, every bone has a name, and each one corresponds to a vortex group section. Inside vortex groups, every group is for an individual bone which has weights assigned to it. These weights tell the bones which part of the model they control. That's how an armature moves the mesh and creates animation. What we need to do now is transfer those values, the vortex groups and their weights. We have to transfer them to our new models. So the original armature can animate it the same way it animates the original models. And it's actually pretty simple. Just follow these steps carefully. Normally, when transferring weights, we select the original model first, then the new one, and then we transfer the weights. But in this case, there is a small complication. Our original character is split into multiple objects, while our new model is just two, and they are full model, like not just small parts. We could transfer the weights one piece at a time, but that usually doesn't give very clean results. So here is a better method. Alright, expand the original armature, and underneath it, you'll see all the original model objects that we imported. Click on the first object, then hold Shift and click the last object, so we select all of them. Alternatively, you can hold Ctrl and select them one by one. When you select them under the armature, they are also selected inside the collections, because all of these objects are connected to this armature. So there is no need to open the red collections and manually select everything. We just already did. And once all of them are selected, this is what you do. Move your mouse to the 3D viewport and press Shift+D, and this will duplicate all the selected objects. Then just hit left click. Now, while they are still selected, go to the object menu at the top and choose Join this option. This will combine all the duplicated objects into one single mesh. You'll now see this new joined object in the outliner. At this point, we have a full combined model, while the original pieces remain untouched. Exactly what we wanted. If you temporarily hide all of the original model's objects and only keep this new object visible, you'll see that it forms a complete model. All the original parts are now merged into one mesh. And it also contains all the original vortex groups and the weights from all the original objects. This is exactly what we wanted. Now we can use this single joined object to transfer weights to our new model in one step, instead of doing it piece by piece. It's faster, cleaner, and gives much better results. So now let's go ahead and transfer the weights. Before we continue, there is a small step that can improve the final results on your new model. In object mode, select your new model, then switch the mode from this drop-down to the edit mode. Go to edit mode. Here, press A to select every vertices. Then press M and choose by distance. A small panel will appear where you can adjust the merge distance value. Set this to a very small number, such as 0.0001, something like this. This will merge any vertices that are extremely close but not properly connected, which can sometimes cause visible seams when the model animates. Not anymore. Now it's time to weight transfer. While in object mode, first, select the joined original object, and then hold Ctrl and select the new model. The order matters, the original first, then the new one, because the new one is the one receiving the weights. And you can pick whichever new model you want first. That doesn't matter. Next, go to the mode drop-down and switch to the weight paint mode. This is the one. As soon as you do this, the new model will turn black in Blender 5. The mesh that changes the color is the one receiving the weights. Now go to the right side here, and at the top, open the weight paint overlays drop-down. Set it to none, and the model will turn blue. Nice. Make sure to do this. Next, go to the left, open the weights menu, this one, and choose transfer weights option. Click it. After doing that, a small settings window will appear in the bottom left corner, this one. Open it, expand it, and change these two important options. First, find the vertex mapping, this one, and set it to nearest face interpolated. Then, go to the source layers, this one, and set it to by name. Make sure these settings are correct. The rest can stay at their default values. If everything worked correctly, you should now see vertex groups appear in your new model's vertex groups section. That means the weights are transferred successfully. Next, we need to repeat this for each new object we have. So go back to object mode. Then select the original joined object first, just like before. Hold Ctrl and select the new one, new model. This time I go with the out of it. Switch to the weight paint mode. Go to weights, transfer weights, and the weights will transfer again. Since the settings are already correct, you don't need to change them. So that's it. Once you transfer weights to all the new models, which I already did, I have only two, go back to object mode and select the joined original object after you're done and press delete. We don't need that anymore. Now, we need to connect the original armature to our new models. Select one of your new model objects, then go to the Properties editor and open the Modifiers tab, the wrench icon. Click Add Modifier option. Go to Deform and choose Armature. It's the first one. This will add an armature modifier to your model. We need this. Now, in the Object field, which is this, click the drop-down and select the original armature. This is it. You can tell by its name. It's the same one as in the outliner. Now, the original armature will control this new model. Repeat this for each of your new models, one at a time. Add an armature modifier and assign the original armature. Just remember not to apply the modifier. Leave it as it is. And now let's test it. Select the original armature, switch to the pose mode, and rotate a few bones, for example, the shoulders. If everything was done correctly, your new model should move together with the original skeleton, which it does. If that happens, then you did it right. Well done. Now the only thing left is to finalize and refine the results. Now, in object mode, hide all the original model meshes, so only the new model remains visible. We are about to do something important. Next, select the original armature again and switch to pose mode. What we are going to do now is test the rig. Start moving different bones and watch the model carefully. Begin with the shoulders, then test the legs, especially areas with joints, since those are the places where problem usually appears, and those are the ones mostly move in the game and bend much. If you notice anything strange, for example, a part of the model not moving when it should, that means that bone, doesn't have proper weights on that area. For instance, if the shoulder bone moves the arm, but not all of it, but it should have, this means that area didn't receive weights during the transfer. This can happen if the new model didn't overlap perfectly with the original mesh during the weight transfer. It's a common issue and we can easily fix it. Leave the model in the pose where the problem is visible. Then switch back to the object mode. Now select the new model object that has the issue. We'll fix one mesh at a time. For me, it's this body model. With the object selected, switch to the weight paint mode. Now go to the Properties panel. Open Object Data Properties, the green icon, and look at the Vertex Group section. Each vertex group corresponds to a bone that influences the mesh. When you select the vertex group, you'll see colors appear on the model. These represents the weights values. To make things easier to see, you can temporarily hide that of it, or hide the armature. No problem. Now go through the vertex groups one by one. You can use the direction arrow keys to move through them quickly. Watch the model while doing this. When you see the problem area light up with the weight colors, that vertex group is likely responsible for controlling that part of the mesh, so stop there when you find it. Once you find that vertex group, do this. We have some options on the left, these ones. Select the brush tool, which is this one. The brush has a value and a size setting. The value controls the weight strength. Red means maximum influence, yellow is mid, green is low. Blue means zero influence, which means it won't move at all. If you want to add influence, increase the value. If you want to remove influence, set the value to 0. For example, if a bone should control an area but currently doesn't, you can paint that area with a higher value, maybe around 70%, so the bone starts affecting it. After painting, you should see the mesh now moves correctly with that bone. Sometimes you'll need to do the opposite. For example, if an arm bone accidentally affects parts of the belly, like this, the belly moves with the arm. That's not what should happen, right? In that case, set the brush value to 0 and paint over the area to remove the influence so it doesn't move. That's how it works. You get the idea, right? Good. And remember, sometimes more than one vertex group is responsible for the same area. So go through all of the vertex groups and check them all and fix them all. There is also another very useful tool which I use most of the time. It's this one, Blur Brush. This tool is mainly used to smooth the weight transitions. Sometimes weights can be very sharp, and when the model bends, it can cause ugly deformations. This will fix that. With the Blur Brush, you can gently paint over those areas to smooth the weights like this, which usually improves the deformation and makes things much smoother. There is an automatic smooth option too, but I prefer this. Gives you much more control and better results. Spend like 20 minutes on this fixing area. Fix the weights. About 20 minutes. It's worth it. The final results will be flawless. Make sure to check all your other new objects as well. Even if they don't show any deformations when posing, it's still a good idea to smooth their weights for better results. Also, pay close attention to this. If the weight values of surface mesh, like my outfit, don't match the underneath model, for example, my body model, then during animation, during posing, they can clip through each other. This happens because they are being influenced differently by the same bones. The weights aren't same. So keep that in mind and make sure the weights are as close as possible. And that's pretty much everything you need to know about weights. Let's go back to object mode and continue. Now that we've finished posing the model to fix the weights, we need to reset the pose. Select the armature in object mode, then switch to pose mode, then press A to select all bones, then go to pose, clear transforms, all. This will reset everything back to the default pose. Once that's done, switch back to object mode. Now we are ready to move on to the next step. Now, unhide all your original models. It's time to choose which model we want to replace. Next, hide your new models for now. So, we need to pick an original model object that our new model will replace. We've already done most of the hard work. Now it's just a matter of renaming the new model objects to match the original ones so the game recognizes them as replacement. Which one should you choose? I usually recommend selecting the model that has the armature in its collection. For me it's this one, but others works too. You can even replace them all. So once you've made your decision, hide the rest of the objects or collections. Don't delete them. We'll need them later. Just hide them for now. Leave only the original models you plan to replace visible. Then unhide your new models again. Now, before we replace anything, there is something very important you need to understand, and that is materials and textures. Every original model comes with its own material, and each material is linked to a texture. For example, if your new model has a separate textures for the body and the outfit like mine, you can't replace both of those objects with a single original object. Instead, you need to replace the body, which is a separate object, with one original separate object, and replace the outfit with another. They have to be separate, because each one has its own texture. Simple, right? Now, here is another important thing. Sometimes your new model might look like one single object, but it actually has multiple materials, meaning different textures are applied to different parts of the same mesh. That's a problem, because you can't assign multiple materials to a single original object, not when we are modding RE engines at least. So in that case, you need to separate your model by material and then replace each part individually with the correct original object. Materials are what we use to add textures, so it's the same thing. Each texture needs to have a separate object. Now, to check your model's materials, you can simply expand your object and this thing here. Then you can see the materials. These things here are materials. If you see more than one for one object, then you need to fix that before moving on. You have two options. The first one is to separate the object by material and then assign each separate part a different original model. The second option is to merge all those materials and textures into one. So your joined object will also use a single combined texture. Then you only need one material for it. This is actually what I did for this model. My body texture was separate, one for the legs, one for the arms, and one for the torso. So I combined them into one single texture and made sure the model supports it. It's a useful method, but not necessary. If you want to do that, I have a separate video where I explain it step by step. It's this one. Link is in the video description. Now for the first option, separate by material, here is how you do it. Select your object, go into edit mode, press A to select everything, then right click, go to separate and choose by material. This will split your model into multiple objects based on your materials. For each material you get its own separate object. And just like that, you're ready to assign them properly. So overall, I have two objects, which means I only need two original model objects to replace them with. In my case, I choose to replace the body with t-shirt cloth 01 and the out of it with bandage. Now, let's see how the replacement actually works. First, we need the material from the original object. Select the original model object, then go to the Properties panel, and at the bottom, open Material Properties. It's this one. Here, at the first option, you'll see the material assigned to that object. Double-click the material name. After it's selected, press Ctrl+C to copy its name. Now, select your new model, the one you want to replace it with. Now, this time in the Material Properties, you see this model's material. Make sure it's selected. Then, click on this drop-down list, this one. Here, you can see all the materials in Blender. Paste the copied original material name into the search bar. Then it will bring it up. There we go. Once you find it, select it. And just like that, your new model now uses the original material of the object you plan to replace. Now, it's time to replace the object itself. Double-click the original object's name, the one you plan to replace the new one with. Press Ctrl+C to copy it. Then click Away to deselect the name. Now, with the object still selected, the original one, press Delete to remove it. We need this gone now. Next, select your new model object, the one we just replaced its material. Double-click its name and press Ctrl+V to paste the copied original object's name. Perfect. Now the game will recognize this as the original object. Finally, drag your renamed object into the same collection where the original object was. This step is very important. If you place it in a different collection, it won't work. And it will come to the bottom. That's fine. And that's it. You've successfully replaced the object. Now, just repeat the same process for the rest. I only have one more out of it. First, get the original material from the original object and assign it to the new model. Then copy the original object name and delete it. Now, rename your new object. And lastly, move it into the correct collection. Drag and drop. Take your time and do it carefully. And I am done. Important note. If you run out of objects in one collection and you need more to replace, you can always use other objects in other collections. That's totally fine. Now, in this collection, you only want to keep the objects you've replaced, meaning your new objects. Anything extra that's still left, you can delete it. You can keep it if you want, but remember, that will also show up in the game on your model, which is usually not what you want. In my case, I don't need anything extra, so I'm gonna remove them all. Simply select the unwanted object and press delete. But be careful, do not delete the objects of the collections that you haven't replaced anything yet. meaning they have no new objects in them. Don't touch them yet. For now, leave them as they are. We get to that later. And that's all. We are done with objects. It's time for their textures. Now, as you can see, the model is currently using the game's original textures. What we need to do is replace them with our custom textures, using the materials inside the MDF collections. But before that, let's prepare our texture files first. Go ahead and find your new model's texture files on your computer, on your drive. These are mine. Now, there are few different types of textures. Base color. This is the most important one. It defines the actual color of your model. NormalMap. This adds surface detail and it actually looks purple. Alpha map, also known as opacity, occlusion. This is a black and white texture, used to hide parts of the model, commonly used for things like hair or fabric details. My short jeans is using this. Depending on your model, you might have all of these, or just some of them. The most important one is base color. You absolutely need this. If you don't have an alpha or normal map, that's fine, we can work that out. Now, let's talk about formats. We need all of these textures to be in text format. That's what RE Engine is using. Right now, mine are in PNG, yours can be JPEG or whatever. First, place the textures you're going to use in an easy-to-access directory, only the ones you actually need. Then, copy the folder path from the address bar like this. Now let's head back to Blender. In Blender, move your mouse to the viewport and press N button on your keyboard to open this side panel. Here, you should see an RE Mesh tab. This is it. Open that one. You'll see a lot of options here. Don't get scared now. Find RE Text Converter, this option here, and expand it. Now, in the Convert Image Directory field, click on this. Now, in the opened browser window, navigate to your texture folder, the one that we just copied its path. Mine is right here. Then confirm. Click Accept. After that, click on Convert Directory to Text. A new window will pop up. Here, we need to change a few small settings. For your base color texture, set the compression to BC7 sRGB, this one. This is specifically for color textures. I have two base colors, one for the body and one for the outfit, and I set them both to sRGB. Done. For everything else, like normal maps, alpha maps, and similar textures, set them to BC7 linear. And once that's done, make sure Generate MIP Maps is enabled too. Then click Convert and wait. Blender will freeze during this process, and that's normal. It takes usually about a few minutes. After it's finished, go back to your textures folder. You'll see a new folder called Converted. Open it, and inside, you'll find all your textures converted to the correct format. They will have the same names, just with a different format, exactly what we need. Leave them here for now, and let's move on. Now, it's time to create the path for our files. What we need to do here is recreate the game's original directory structure for our modded files, for our edited files. Once that's done, we can move on to assigning the textures and finally export and pack everything. So inside Blender, go back to the layout workspace where we started. In the asset browser, navigate to the file we are modding. For me, it's Gray's default torso 00. That's the one I replaced. Find it and select it. Now, click Open Asset Location, this option here. This will show you the original file path for the selected model. This is where Blender extracted the game's files after unpacking them from game's raw files. We are going to recreate this structure in our own directory. Here is what you do. Go anywhere on your drive and create a new folder and name it something. For example, I name it RE9. Then open it. Inside that, create another folder, and this one can be named after your character or your mod. It doesn't matter, but it's something public sees. But this will be your working folder. It's important. And everything will go inside this one. Now, open that folder too, and from here on, we start recreating the game's original path. So this is the original directory, and this is the new one. Look at the original directory. You'll see a folder named RE-chunk000. You're gonna start recreating the path after that, meaning starting from the natives folder. So, in your new directory, create a folder named natives. We create a new folder and name it natives. Simple as that. Then we open it and create the next folder. For me, it's STM. And keep going step by step. You're basically recreating the exact same folder structure, one folder inside another. Make sure the names are exactly the same. Spelling, capitalization, everything. Triple check this, because if one path, one folder is wrong, your mod will not show up in the game. Continue until you reach the final folder, the one that contains your files. In my case, the file is Grace default torso 00, and the folder is named 00. And I am done. You can close the original path after you're done. So this is how it's gonna look after it's finished. Something like this. Yours be very similar to mine. Now, one important note. If you replaced files from other collections, then you need to recreate that path as well, not just one collection. Every collection you plan to mod, you need to recreate them. But I only replaced one collection files. For now, I just stick with this one. We explain more in detail later. Alright, now get your texture files, the ones we converted to text. Copy all of them, these are mine, and paste them into the newly created path for your model. The exact folder your model is gonna be in. Paste them there. It's best we place the textures nearby our model and material folder. Perfect. Now the textures are inside the right place and ready to be assigned in Blender. Keep that folder open and go back to Blender. Now in Blender, switch to the modeling workspace and make sure you're in the object mode. It's time to edit the materials. Each model has its own collection, the red collection for the mesh, the blue collection for the material. This time we are working with the blue collection, the MDF collections. So, go ahead and expand your model's MDF collection. This one right here is mine. You can recognize it by their ID. Inside, you'll see multiple materials. These are the ones we will use to assign our textures to, new textures. Now here is something very important. You should only keep the materials that match the objects you actually kept. For example, in my red collection, I only have 2 objects left, but in the MDF collection, I have 5 materials. That's a problem. So what do? Well, we identify the correct ones and only keep them. The easiest way to do this is by looking at their names. As you can see, one of my object names is T-shirt cloth 01 matte, and I have a material with the same name. So I keep that one. My other object is named bandage, and I also have a material named bandage. So I keep that one too. It's that simple. Now, delete the rest. Select them and press delete. Now we are left with only the materials we actually need. And with that done, we are ready to assign our textures to them. Now it's time to assign textures to materials. First, Select your material. I start with the body model material, which is Cloth 01 in my case. After selecting it in the outliner, go to the Properties panel. From this point on, we'll mainly be working here. Go to Object Properties and look for REMDF material setting, this one here. Expand it. Make sure it's open. You can close the other sections if they are open. This is the only one we need. Here, you'll see things like material name, master material path, shader type, linked material, and I recommend leaving all of them as they are. What we need to work with is the texture bindings, which is this option. Go ahead and expand that section. This is where we tell the MDF, the material, that where our textures are, where the texture files are, so the game can find them and apply them to the model. Now, you'll see a lot of texture slots here. Don't worry, we don't need to edit all of them, just some. Also, as you can see, each one already has a path. These are the original game textures path, which is why your model is currently using the game's original textures. What we need to do is replace them. We will start by finding which one is which first. Each texture here is identified by a name. For this game, base dielectric map, this one, is the base color texture. You can also tell by the file name. The last word, the last part in the path is actually the original texture name. That's the file name. And the ALBD, this thing, ALBD, is always means base color. And NRMR is NormalMap, always. As you can see in the name, it also says normal roughness map, so that also confirms it. And ACOT is alpha map, the black and white texture. And in the name it also says alpha cavity occlusion translucent map. So it is alpha map. So ALBD is base color, NRMR is normal map, ACOT is alpha map. Okay, it looks like we find the big tree, and they are always next to each other apparently. So, there are two ways to identify them, by the slot name or by the file name at the end. Anyway, after you find them, we are going to replace their path with our custom textures. And let's do that. Open your texture path, the one we created where we placed all the converted custom texture files. Now go to the address bar and copy the full path like this. Alright, now get back to Blender. So, all of my custom textures are inside the same folder, right? That means the path will be the same for all of them. What we need to do is click on the texture binding path that we want to change. In this case, I'll start with the base color, this one right here. Now pay close attention. You need to identify two things, the path and the file name. The last part after the slash, this, is the file name. We don't touch that. We are going to use the game's original texture file names. So, select everything before that texture name. That would be only the path. And make sure you also select the last slash. Like this, you select everything before the name. Now, press Ctrl+V to paste your copied path, our custom textures path. And just like that, we replace the original path with our custom texture path. Exactly what we wanted. Now, at the end of the new path, right before the original file name, add a backslash, like this. Now, it's complete. Click away to confirm, and that's done. Next is the texture name. At the end of the path, select the full file name, only the name, like this. Press Ctrl+C to copy it. Now, go back to your custom texture folder. Find the corresponding texture. Since I am working on the body base color, I need to find my body base color texture, which is this one. I named them in a way that I find them easily. Now select it and rename it. Press Ctrl+V to paste the original texture name on your custom texture. And done. Also make sure you don't change the number at the end of the .text. That's the format actually. Leave that exactly as it is. So now one texture is set. Just remember, the name must be the original texture file name, but the path in the other hand can be anywhere, as long as it is inside the STM folder. And the name of the texture can be from any original texture from the game, not just from the specific model. Now let's do the rest. Copy the custom texture folder path again and go back to Blender. This time I'll set the normal map, this one right here. Same process. Replace the path, add backslash before the name, copy the original texture name, then go back to your custom texture folder, find the corresponding normal map, this is the one for me, and rename it. Done. My body material is fully set. Now, you might be wondering, what about all the other textures here? Do we need to replace them all? Not all of them. We'll get into that in a moment. For now, just focus on assigning the textures you actually have. Alright, now it's time for my out of it material. Same process. Select the material, go to the object properties, then into the texture bindings, and find the texture types you're gonna change. In my case, I have base color, normal map, and an alpha. And these are the bindings for them. So I go to my custom texture folder, copy the path, and start replacing them one by one. First, the base color. Replace the path, add a backslash before the texture name, copy the texture name, find the matching texture in the custom texture folder, and rename it. That's done. Then the normal map, same steps. Then the alpha map, same steps. And that's it. I am officially done. This was the most important part, and it's done. So you might be wondering, we changed the textures in the material, but why aren't they showing on the model yet? The model still looks the same, right? Haven't changed. Well, that's because we haven't applied them yet. We just changed them, set them, not applied them. Now we are going to do that, but keep in mind, this step is not necessary. So here is what you do. Press N to open the side panel. Then go to ReMesh. Now here, find and open ReMDF tool. This one, expand it. Now find and expand MDF preview, this option. Here we have view settings to configure. First, active MDF material collection. In this section, we have to select the MDF collection that contains our model's materials. For me, it's this one, so I select this one. Next, in the MDF preview section, choose your mesh collection, the one that contains your model. For me, it's this one. Now for the last option, mod directory. Here, we need the custom path we created earlier, the recreated game directory where we placed our textures. Go to that folder and navigate to the STM folder and copy the path. Make sure you are inside the STM folder. We only need this part of the path, nothing beyond it. Now back in Blender. Click here, and in this window, locate the same STM folder and confirm. Okay, settings are done. Now finally click Apply Active MDF. Give it some time, and after a few seconds, your model should update, and your new textures will apply. Perfect. Now, if the results isn't exactly what you expected, which is expected, for example, if you see weird shading or visual issues like I do here, don't worry, that's completely normal. It usually happens because some original textures are still active in the material and they don't match your new model, but they are still applied. And don't worry, we are going to fix that in the easiest way possible. The three main textures we usually need to replace are base color, normal map, alpha map. For my out-of-it model, I had all three, so I simply replaced all of them. But for my body model, I didn't have an alpha texture, and that's completely normal. It's a body mesh. It doesn't have things like hair or transparency that would need an alpha, right? So, however, the original object and the material we replaced did use an alpha texture. It was a cloth material. Cloth materials use an alpha texture. So that means we still need to deal with it anyway. Otherwise, we'll get issues like this. Now, here is the important part. You can't disable textures in these bindings. They either have to stay as the original or be replaced. If you try to remove one, for example by deleting the binding path, the game will most likely get stuck in the loading screen and never load. This also happens when you set the path wrong or the texture name is wrong. So disabling is not really an option, at least not directly. What we are going to do instead is create a natural alpha texture, one that has no effect on the model. Alpha maps are black and white. Black equals invisible, white equals visible. So all we need to do is make a fully white texture. That's it. I already have a white image. You can download it, you can make it. It just has to be white, clean white. The size doesn't matter. What you need to do next is convert it to a text file, just like we did with the other textures. Then we place it in the same folder as our original textures. And I'll leave a download link for this image in the video description so you can get it from there. Now back in Blender, go to your body model material, the material you have problem with, and find the alpha map binding. And do the same process as before. Replace the path, add backslash before the name, keep the original file name, copy it, then go to your texture folder and rename your white alpha texture to match the original name, just like any other texture we did. Now back in Blender, just click Apply Active MDF again and give it some time to load, and as you can see, the issue is gone. Model looks correct. So yes, it was the alpha map. I wasn't sure. You have to check and see which one is. You can use this same technique for any texture that might cause problem. For example, if you don't have a normal map, you can use a blank purple image, like this one. I've also added a download link for this in the video description. This will remove any normal map effects on your model. For most materials, the big three is enough: base color, normal map, and alpha. But sometimes they need one or two others to be edited. But there is one more I want to talk about, the wet map. Every material has it. The wet map is used when it's raining or whenever the character gets wet. The original texture usually won't look good on your costume model, so I recommend replacing it as well. So what should you replace it with? A white texture. That will do the trick. You can even reuse your alpha texture for this. Since it's just a blank white texture, and that's what we need, it works perfectly. You just copy the whole binding from the alpha and paste it to the wet map. And that's it. You can reuse the same texture multiple times, even across different materials. And that's pretty much it for the textures. Now keep in mind, sometimes your model might look perfect in Blender, but once you see it in game, you notice some visual issues. That's completely normal. I had the same problem. As you can see on my out of it and body model, there are some weird effects, even though everything looks perfect in Blender. If you run into this, just know that these issues are texture related. Some of the original textures is still affecting your new model. After replacing the main three textures, base color, normal map, and alpha, there can still be one, two, or even more textures affecting your model. It depends on your material. The ones that usually cause issues are things like detail maps. For example, I have texture like for detail map, for detail UV distortion map, and for dust imperfect detail map. Basically anything with map in its name potentially affect your model in unwanted ways. So what do? You have two options. First option, you can replace those textures with your custom ones so the effect matches your model, but this requires good knowledge of textures and figuring out exactly which texture is causing the issue. Second option, easier and recommended. We simply disable those effects. Here is how. Select the material that has the problem, then go to the object properties and REMDF material settings. Here, open the property list. Expand it. Now open and use the search bar. Type map, then hit enter. Now you'll get a list of settings related to those map textures. These are usually the ones causing weird effects. If a setting has a numeric value, like it has number in the setting, just set it to 0. That completely removes its effects. If a setting has an enable disable toggle, simply disable it, uncheck the box. That's it. That's how we fix the issue. Simple and fast and efficient. Do this for all materials that have issues. And these changes are saved directly into the material file, so there is nothing else you need to do. After setting those map-related values to 0 and disabling any unwanted option, the unwanted effects should be gone. It did work perfectly in my end. Different materials may have different settings, but the idea is always the same. The issue comes from these extra map settings, and the fix is disabling and neutralizing them. Now let's move on to the next step. Next, we are going to look at the material settings, things like shininess, brightness, metallic value, and more. These are very important, so let me show you. Select your material. I go with the out of it. Now, go to the object properties, and inside REMDF material settings, close texture bindings. This time, expand property list, this one. Now let's see what we have here. There are lots of settings here. In short, they mostly do exactly what their name suggests. The most important one I usually work with is roughness. You can click this small arrow here to open the search bar, then type roughness and press enter. That will bring it up. The one we are looking for is the one with the wrench icon. That's this one. It's very important. You can change its value, increase or decrease it, and you'll see the results directly on the model. If it doesn't update, just apply the MDF again, then it will. But most of the time it's live. As you can see, it controls how shiny the material is. For example, if your out of it is leather, a bit of shine looks good. But if it's cloth, like mine, you probably won't need shininess, so set it to 0. Just adjust it based on what fits your model. Another important one is base color. This directly affects the color of your texture. If I set it to red, the texture will get a reddish tint. So this can be very useful too. If you want to tweak the overall color, use this. And that's basically how these settings work. Most of the time, the default values are fine. But if something looks off, and if it's not related to the bindings, then it's these. You can come here and experiment a bit to get the results you want. Now there is one more important section. Close property list and this time open flags. These options enable or disable certain effects, and they are very important. For example, in my case, alpha map usage is off by default. That means the material won't use the alpha texture, which can make the out of it look wrong. My character's genes are using alpha. I need this to be on. So we need to enable it. So which option controls that? Well, anything with alpha in its name. So I usually just make sure all the relevant alpha options are enabled. I check the box. And that will fix it. And that's it for textures and materials. We are done here. Now let's move on to the next step. Alright, time to export. We are basically done, but before exporting, there are two important things we need to check. Weight limits and loose vertices. First, let's fix the weight limits. Select your new model object, one at a time, then go to the weight paint mode. From here, open the weights menu and find the limit total. This one right here. Click it, and you'll get a small window. Set the limit value to 8. That's the maximum it should be. Now do this for each of your new model objects. In my case, I have 2, so I apply it to both. And after that, go back to object mode. Now for the second step, cleaning loose vertices. Again, select your new model object, one at a time, and go into edit mode. Press A to select everything, then go to mesh menu at the top, find cleanup, and select delete loose. That's it. Repeat this for all your new models object to make sure there are no loose vertices left. And that's it. Go back to object mode, and now we are ready to export. Now the way we export is collection by collection. The mesh collection and the material collection are exported separately. So Blender won't export everything in the scene, which means you don't need to delete anything. Just leave everything as it is, and we are good to go. It also won't export those faded objects under the armature, which is perfect. Let's start by exporting the mesh collection, the one that contains our new models. For me, it's this one. Here is how. Go to File, Export, and in this section, you should see ReMesh Editor, the add-on we installed. Open that, and choose ReMesh Model. Now, we get an export window. Let's check the settings. On the right side, for mesh version, select the game you're modding. In my case, that's Resident Evil 9 Requiem. Next, and this is the most important, in the collection field, open the drop-down and select the collection that contains your new model. For me, it's this one. Now, the file name, this is very important. Do not change it. By default, it's already correct. It matches the original file we are replacing. Because it's linked to the collection, they are matched by default, so just leave it as it is, it's fine. Now, where do we export it? We export it to the same path we created earlier, the one we also used for textures. Navigate to that folder in this browser window, and once you're there, click Export ReMesh and wait. It might take a few minutes. After it's done, you will get a notification message. If there is no error, you're good. And that's it, the mesh is exported to its correct path with its correct settings. Now let's export the materials. Go to File, Export, ReMesh Editor again, but this time choose ReMDF Materials, this one. You'll get a similar export settings, just like before. Set the MDF version to your game. For Resident Evil 9 and Pragmata, it's the same option. Then select the correct MDF collection, the one that matches your mesh collection. For me, it's this one. Again, the file name is already correct. Don't change it. Now navigate to the same folder as your mesh file. The MDF file is always goes next to the mesh file. And click Export MDF Materials. This one is very fast. It should finish almost instantly. No error means everything is good. And that's it. Technically, we are done. We've replaced the files, and they should work just fine. But there are still a few final steps to complete. So let's do that next. Now, if we pack and install the mod as it is, it will work. It will replace what we've replaced. But here is the problem. We only replaced the torso. That means all the other parts of the original model, like the legs, hands, and head, and anything else, will be still there, visible. So in game, those parts will still show up, and they overlap with our new model. The only part that won't overlap is the torso, because that's the only one we replaced. Everything else is still there, along with our new model. Back in Blender. So the rest of the original models are still here, in these other collections. Now, we are not going to start over or anything. We already replaced the main model successfully. The only thing left is get rid of these extra objects in our way. Now, you might think we just delete everything and export empty collections, but that won't work. Our image does not export empty collections. So here is our options. One way is to delete almost everything and just keep one object in each collection. Then select the object, go to edit mode, delete about 99% of the object, and then leave only very small piece. After that, go back to object mode again and scale it down even more. And place it somewhere inside your body model, the model you replaced, where it won't be visible. Then export it normally, only that collection, and place it in its own path. This basically hides the object and it works. There is also another way. You can also use materials to hide them. For example, if you check this option in the material settings, it will make them invisible. Your objects that are using this material will be invisible, which I think it's the best one to use in my case. So back in Blender, we have legs, 2 arms, and the head. Leave the head alone for now. I'll explain that in a moment. Let's start with the legs. Go back to the layout workspace where we started, and in the asset browser, navigate to your character's model folder. Find the model you want to make invisible. For me, it's the legs, this one. I select it. Then we click Open Asset Location, so we get its location, because we need to create its path. Now, go to your duplicated mod folder, the one we created earlier. Since it's the same character, most of the path will be identical. Only the last 1 or 2 folders will be different. Let's create the missing folders accordingly. I go into the 0 to 100 folder, create a new folder there and name it 50. Then I go inside that folder and create another new folder and name it 00. Now the path for the leg is ready. Copy this path. Now go back to Blender. Switch to the modeling workspace and make sure you're in object mode. And open the legs MDF collection. This is the one for me. Expand it. Each material here belongs to a part of the leg model, the one we want to hide. To make them invisible, select each material one by one. Then go to the Properties panel, Object Properties, REMDF Material Settings, and expand the Flag section. And enable Make Material Invisible. It's the first option in the flags. Check the box. Do this for all materials related to the legs. One by one, I select the leg collection materials and check this invisible material option. Once that's done, we are ready to export. This time we only need to export the MDF, no need to export the mesh. I am done, let's export. Go to File, Export, and REMesh Editor, then MDF Materials. Now in the export window, just like before, make sure the game is set to RE9 and double check that the correct collection is selected. This is the one for me, and the file name should already be correct. Now navigate to the path we just created and export it there. That's it. The legs are now invisible. Now repeat the same process for the other parts as well, the ones you want to hide. In my case, I do it for the arms as well. Find their paths in the asset browser. Recreate those paths in the mod folder. Enable Make Material Invisible option for their materials, and export the MDF files to their correct location with their correct settings. No need for their mesh files. Okay, I'm done. Now about the head. In my case, the head looks fine and doesn't clip, but if it does clip with your new model, you can't just make it invisible like the others. Instead, you'll need to edit either the out of it or the head mesh file. For example, if clipping happens, you can adjust the out of it so it fits around the head, or modify the head so the head fits the out of it or the body. So let's say head is clipping, and we want to edit the head to match the body. This is how. So in the outliner, go to the head mesh collection, this one in my case, and expand it. Also make sure it's visible. Now let's say we have a clipping issue like this, and we want to fix it by editing the head model. First, inside the mesh collection, check if there is any object you can simply delete. In my case, the bandage looks unnecessary, so I select it and delete it. And always remember, when you delete an object in the mesh collection, make sure to delete its material in the MDF collection as well. Okay, that's done. And it was the only one I could remove in object mode. Everything else needs to be edited in the edit mode. So let's do that. Hold Ctrl and select all the remaining objects in the head mesh collection. Then switch to the edit mode from the mode dropdown. In edit mode, you have full control. You can select any part of the model you want, either delete or adjust it to fix the clipping. You already know how to delete. Just select the parts you don't need. The parts are in the way, and press delete, and choose vertices or faces, and they are deleted. Now to move parts of the mesh, do this. Select the area you want to adjust. You can select one or multiple vertices at the same time. Then use the Move, Rotate, and Scale tools on the left to edit. Most of the time we use Move. If you try to move it now, you'll notice it's very sharp and affecting only a small area. To make smoother adjustments, go to the top bar and enable proportional editing, this one. Now when you move the vertices, the surrounding area is affected as well. While moving, use your mouse scroll wheel to adjust the influence radius. You'll notice a circle that shows how much of the mesh is being affected, being influenced. This makes it much easier to smoothly adjust parts of the mesh. For clipping issues like this, you can simply push the problematic areas slightly inward so they sit properly inside the body model. That can fix the clipping. And that's it. That's how you fix clipping on the head mesh. But as you can see, my out of it is actually helping a lot here. So what if you don't have an out of it like this, and it's just a body model? Let's hide the out of it for a second and find out. Now the clipping is much more visible and a bigger problem. In this case, what you could do is choose a connection point between the head and the body. I usually prefer the neck area. What I do is delete parts of the head mesh down to the neck, like this, somewhere around here, and try to cut it as straight as possible. Then I select the vertices and use the Move, Rotate, and Scale tool to adjust them so they match the body. You can make it perfectly aligned, but it's not necessary. Just get it close enough, something like this will work fine. After that, you can hide the seam, the gap between them, between the head and body, using something like a choker, a collar, or any accessory. That's a common trick we use. I have some in my Patreon, you can check them out. Or, if you want perfect results, you can dive deeper into Blender and make it pixel perfect. For that, go watch some additional Blender guides. There is one more important step here to keep in mind, and that is skin tones. You see, my head model is using its original skin tone, and my body model using its own skin texture. And they can have very different tones. We need to match them. I recommend trying to match your new skin with the original. To do that, you simply edit your new texture file. You can do that inside any image editor, like Photoshop. We simply edit settings like brightness and stuff. That's it. So once you've edited the head mesh and fixed the issue, we just export it. First, like with any other model, find its original path and recreate it. Then we export it, but there is one important thing. Before exporting a collection, make sure it contains an armature. Right now, our armature is in a different collection. So simply drag and drop it into the collection you want to export. No need to rename anything. It's done. Now you can export. Go to File, Export, REmesh, REmodel. Set the correct game, choose the correct collection, select the correct path, don't touch the name, and export. Perfect, that's done. And don't forget the MDF file. If you skip this, your model will appear textureless in game. Export the MDF file of the mesh file as well, just like before. And that's it. That's how you handle the head. Alright, final step. Packing and installing the mod. After exporting all your files and everything is ready, go to your mod directory, the one that we made and contains all our edited files. Now go to the main folder we created, the one that contains natives folder. In my case, it's called Grace. Now copy the full path of this folder. Now head back to Blender. In the viewport, press N to open the side panel. Go to REmesh. Then find REasset extensions and expand it. This one. Now look for the option called Create Pack Patch and click it. You will get a new window. You have two sections. In the mod directory path, click here, and in the browse window, navigate to the folder that contains your natives folder. Paste the path we copied. I am here. For me, that's the Grace folder. Now, I confirm. Okay, that's it. For the pack output path, the other option, you can choose anywhere. It doesn't matter. So I go with this directory. Now, click OK. After you click OK, it will start packing your mod. And after a few seconds, it's done. The output folder should open automatically after it's done. And you'll see a pack file listed there. That's your mod file, ready to be installed. To install the mod, we are going to use Fluffy Manager 5000. First, let's download it. Go to the official website and download it from there. The link is in the video description. You'll get a zip file. Open it and extract the files inside it, all of them, anywhere you like. Once it's extracted, open the modmanager.txt file, this one. If you see a security warning, just ignore it and click Run anyway. It's safe. Now you'll get this window. The first thing we need to do is select our game. Scroll down and find your game. In my case, it's Resident Evil 9 Requiem. This is it. I select it. After that, the manager will automatically find the game path and open this menu. Now in this menu, go to the download section. Here, we will find an RE framework, which is this option. Click on it after you find it, and let it download and install. We need this. It's a requirement for our mod. Once it's finished, go to the mod list section, which is here. You'll see the RE framework entry, which is this one. Enable it to install it. And that's it. We are now ready to install the mods. Close the mod manager for now. Next, Go to the folder where the mod manager is located. You'll notice some new folders have been created. Open the Games folder. Then open your selected game, in this case RE9. Inside, you'll find the mods folder. Open it. This is where all your mod files go. Once you place your mod here, it will show up in the manager and you'll be able to install it. So now, let's get our mod file ready. First, let's take a screenshot of our mod in Blender. We'll use this as a preview image for our mod. You can always change it later, but for now, we just need a picture. I will use this one. Place this image in the same folder as your pack file. Next, create a new text file where your pack file is. Right-click, New, Text Document. Then rename it to modinfo.ini. Make sure the file extension changes from .text to .ini and confirm it. Now, rename your preview image to something simple like preview pic. The format doesn't matter. Okay, open the modinfo file using Notepad or any text editor. Now we'll add some basic information for the mod. Now let's start adding. Type name, then add equals, and then your mod name. I name it Grace. Now hit enter. Next, type description, then add equals, and add a short description. You can type anything you like. Then hit enter. Now, type author, and add equals, and put your name or brand. Finally, type a screenshot, and add equals, and now copy the name of your preview image, the name with the format. Then paste the full name of your image, including its format, in front of the screenshot, like this. This will be your image preview in the mod manager. Once you're done, go to File and Save, then close it. Now, select the mod pack file, the preview image, and the mod info file, all three, and right-click, then go to WinRAR, and choose Add to Archive. Now in this menu, in the Names section, give your file a name, anything works. I go with Grace. And here, choose a format, RAR or zip. I go with RAR. Then click OK, and give it some time to archive it. After it's done, you'll get a RAR file. This is your final mod packaged file. And if you don't have WinRAR, you won't get these options, so make sure you download WinRAR and install it. It's free. Okay, copy this, then go to your mod manager's mods folder and paste it there, next to the RE framework. Now, go back to your mod manager X file directory and launch it. Now, you should see your mod listed there, usually under the MISC section, here. Now, when you bring your mouse on your mod, you'll see the details you added on the left side. And click the mod to install it. Click it again to uninstall it. Now install the mod and launch the game. Once the game starts, you'll see the RE framework menu in the top left corner. Wait for it to load. Then find this option, Loose File Loader. It's this one, expand it. And inside, enable Loose File Loader option, this one. Check the box. This step is very important. Without it, your textures won't work. And after that, close the menu. And check your modding game. Make sure your character is using the out of it, the model you replaced. Only those will be affected, that's why. And as you can see, everything works perfectly and looks perfect. Well done, that's all. Now the only thing left is physics. Right now the model does have physics, but they are coming from the original model. In some cases, you might want to create custom physics for better results. For that, we'll be using the Chain Editor add-on to add custom physics for our model. I cover all of that in a separate physics guide. That's it for this video. I hope you enjoyed it. If you have any questions, feel free to reach out to me on my social platforms, or just leave a comment under the video. I get back to you as soon as I can. And don't forget to support me through Patreon or Ko-fi. If you like to help, that will help. Thank you for watching and good luck with your modding.